Hello, Namaste children. Welcome back to the class. Today we'll be learning a story of numbers from class 8 NCERT Ganit Prakash. So here is one beautiful story what how the numbers have came in our life. Let us see about that. One beautiful story about the Rima's curiosity. One lazy afternoon, Rima was flipping throughout through an old book when she saw a piece of paper slipped out and floated on the floor. She picked it up and stared at the strange symbol all over it. What is this? She wondered. She ran to her father, holding the paper as if it were a secret treasure. He looked at it and smiled. The father said, around 4,000 years ago, see children, around 4,000 years ago, there was a civilization in which a region called Mesopotamia, right? Mesopotamia in the western part of an Asia. They contain a major part of the present day, that is Iraq. So today what we call as an Iraq. And a few other neighboring countries, which was the one of the ways they wrote their numbers. So this was the symbol what they have written. Right? So 1, 2, 3, 3 plus 1, 4, 3 plus 2, 5, then again 3 plus 3, 6, 7, 8, and 9, so on. So Rima's eyes lit up seriously. These strange symbols were numbers, and she was very curiosity to know about this. Then the father explained about that how the symbols have came. So how the people, the old peoples, that means the 4,000 years ago, how they used to write. They represent with the some numbers, that is over the course of time they finally reach it in the modern efficient form. So they travel back in the time which we have learned earlier about the story of the numbers. So we know very well that today's world without the number for anything in our daily life is very important and it's very necessary. Right. So now here we will learn today's number is nothing but the form what we are writing, that is our numbers, that is 0 through 9, and it will be originated with and developed in India around 2000 years ago also. But the first known instance of numbers being written using 10 digits including the 0, right, including the digit 0, which was noted as a dot, right. And so it's shown that the Bakshali manuscript, which was in the third century, right? Third century, that is C. And Aryabhatta in the 499 century, which was the first mathematician to fully explain and they elaborate the how the scientific computations with the Indian systems of 10 symbols. So let us see about that how it has been gone through. So here is one small picture, 0 in the Bakshali manuscript, right? How they have been denoted with the dot, what we have learned just now, with that is 0, with the digit of 0, which was noted as a dot. And in the first mathematician to fully explain, that is our Aryabhatta, how they have represented, let us see that one. The Indian number system was transmitted to Arab world by around 800th century, and it was popular in the Arab, which was known as great Persian mathematician Al-Khwarizmi. So after whom the word called as an algorithm. So the name was after that it was mentioned as an algorithm. So nowadays we are not using algorithm children, where only just we are in the computer algorithm chart. Okay, that is a fine. It's a extra knowledge for that. So and for the noted like philosopher Akindi through his work on the use of Hindu numerals in the 830 century. And we know very well that these all are the mathematicians what we have seen further what they have done. And one more, the great mathematician what was there, that is a Italian mathematician Fibonacci, who around the year 1200, which is made the case to Europe to adopt the Indian numeral. And see, we have to be proud that so much of our India has done. And and I feel that I am very proud to be an Indian. One thing that is okay. The Roman numerals were so ingrained in the European thinking and writing all the time, and the Indian numeral did not gain widespread use of several more centuries. See, the many after in spite of this, our Indian numerals was very rare to go all over the world, right? So that's why it was not so popular. So later, during this European Renaissance and the 17th century, it was not adopting that became impossible, or it would be impaired scientific progress. Then later it has totally, it was going like a vanished for us. Then let us see that how much they have become to the important, and which was the important, and let's see. Okay, here was a very good evaluation of the digits what they have mentioned by the NCERT. Evaluation of the digits used in the Indian number system. So we will see that what are there. First was we called as an Brahmi, right? In the Brahmi they mentioned with the Hindu lipic, which is known as called as an Gwalia, and in Hindu lip year there was a West Arabic Gubar and the East Arabic also. See, in that Arabic also it's mentioned as in West as well as East. And then later it was called in Hindu Galiar, that came as a Sanskrit Davanagiri. Right, Davanagiri. And it was the 11th century, which was. And then later in the 15th century and in the 16th century it's called as Adva. Right. So these all are the names. It's very difficult for us to pronounce. So maybe the people, maybe the old people, olden peoples, they used to name in such a way that they it was easy for them. Today's we are very difficult for that. Okay, fine. So next, the first one we will see about the how the mechanism of the counting starts. And this the mechanical mechanism of the counting, it was start with the some methods. We don't know what was the method till now. We have seen about the topic how the number has evolved. That means today we will call as a number, but earlier it was a different. The name was totally different. So in what way the earlier people, the older peoples, the our ancestors, they have counted the numbers. Let us see that one. Right. So imagine that we are living in the Stone Age. So today we are living in the Stone Age. We are not in the modern age, that is computerized, modern technology. And today we says that it's very difficult for us today, right? In the Stone Age, sorry, not today, Stone Age, but today we have lot of, we are pinned in the modern day, that is our today AI generation, what we say today, Generation Z or Alpha. So that it shows that how much of today we have been came in this. So let's see, how do we ensure that all cows have returned? Sorry. They're living in the Stone Age, say around 10,000 years ago. We have to herd of cows. Here are some natural questions that we might ask about herd. So what was that? So in the Stone Age, how the people used to, for example, when they were grazing, cow was going for grazing. So how they ensure that all cows have returned safely after the grazing? How many cows they have taken? So how they remember, or they think, or they count how the whether the cows have came or returned back or not to their shed. Do we have fewer cows than our neighbors, or else our with our cows any neighbor cows also have came? If there are fewer, how many more cows would we need so that we have the same number of cows as our neighbor? So how many cows have are with us, and how many more are there, or in spite we can say that how many less also we can say vice versa. So how to tackle these questions? That will let us see that one with the use of the number name called as an written number of the Hindu number system. So let us see here what are the methods are there. Let us see that how it has came in our daily life, right? So method one, the first method what is there, we can tackle the question by using the pebbles. Remember pebbles and sticks or any object that is available in the. Let us see. So the first method was saying by how to go. We'll by using pebble, sticks or object. So let us choose sticks. We will take the sticks. For every cow in the herd, we keep a stick. The final collection of sticks tells us the number of cows which can be used to check many cows. Like for example, when we make a cow to stand, when in each front of the cow, we can keep the sticks here. Then when we keep the sticks in front of the cow, then together we can say that, yes, this many cows today are there. And after returning back from the grazing also, then one more again, once again, you can keep the stick in front of the cow. Same sticks at the morning time, what when you are going outside, same sticks, group of the sticks you can take it. And that stick says that, yes, if it is a correct, yes, correct. If it is a less, then if two remaining is there, means that means two cows have to come back again, or two cows are missing, we can say. If it is a two cows or more, then after getting the group of that cows, for example 10 cows are there, then 10 cows, what do we have, same 10 cows, 10 sticks of the cows will be the same with us, but the cows are more, then two or three cows are more, two cows are more, then we can say that, yes, the two cows are more with maybe some other person's cow. Okay, let us see the next one again. This way, the associating cow with a stick, and that two no cows are associated or mapped at the same stick, which is called as one-to-one mapping. So this way, this method is called as an one-to-one mapping, right? And this one-to-one mapping is very first method is very easy, they says in that way. And this used to come up with a way to represent the numbers as shown in the table. 1, 1, 2, 2, 2 6, 3, 3 6, 4, 4 6, 5, 5 6, 6, 6 6, 7 7 6. But here the method has been failed little bit. If it is a more means what we can do it more than 30, 40, then it's very difficult. So let us see the next one, which is the method 2. So what is the method 2? Let us see that one. Here's one question. How will you use such sticks to answer the other two questions? Right? The other two questions what we have learned here. Do we have the cover how the neighbors have came, and how many numbers the cow we need, so have the same number of the cows as we neighbor. So let us see that one. Then in the method 2, we'll learn how for the remaining two questions. Instead of these objects, we use as a standard sequence of sound or names. For example, we use the sound of the letters or of any language. While counting, we count, make a one-to-one mapping between the objects and the letters. See, with the first method were called as a one-to-one mapping. Same thing in the method 2 also, we can go with that, the objects and the letter with the sound of the letter. So what is that sound of the letters, right? And in this associated with object to be counted with a letter, the following the letter order are there. This mapping can be then by used to come up with a way of verbally representing the numbers. Like example, we get the following numbers like use English letters A to Z. All right. So how we are mapping that one? English A to Z, right? So this, like number 1, it's A, 2, B, 3, C, 4, D, 5, E. But up to Z we get only 26. Then what about more than that? So only 26 only is the last. For example, if you have the 40, then what you will do? So 40 means 40 numbers are there. Then up to 26 only it's there. It was very difficult for us. So that's why, so English alphabet, what is said, the 26 letters. So next, that is, and obvious limitations was there. So that was using only the letters of the English alphabet in this form is that it cannot be used to count collection having more than 26 objects. So up to 26 only we can say. Then after 26 what we can do, right? So this method also was little bit further has been implemented with this first method and second method. So how many numbers can you represent in this way using the sound of the letters of your language? So he's asking now. Then the next third method, what we see. So we'll do a third method. We could use a sequence of written symbols as follows, right? So what was the third method what we have seen? Here the representative of the sound, that is 1, I, 2, like a Roman numbers, 3, 4, 5, 6, 7, 8, 9, 10, and then up to it represent up to 20, right? It was representing up to the 20. Then after that, what is there then, right? It was a very, if it is a big number, what we can do? If it's a more number, that only I am representing from that. Saying that it is very difficult for go for the bigger number. So from this discussion, we can say that the counting and finding the size of a collection is a standard sequence of object or names or written symbol that has a fixed order. Let us call this standard sequence as a number system. So now it comes the main name which is important, called as an standard system. right? A number system. What is it, that one? A collection of objects can be counted by making a one-to-one mapping between them and the standard sequence. So what is that number system? It is nothing but a collection of objects can be counted by mapping a one-to-one mapping between them as the standard sequence, which is called known as the number system, right? And with this number system we have seen now three methods we have seen. First method, what was there? By using the pebbles or sticks we used to have it. Then in the second method we have seen that by the sound of the letters like a b c d, that letters. But here was the one problem was there, that more, if it is more than 26, what we can do, that was a more problem. And in the method one also, if it's a more six more numbers, it's very difficult to count that one. And the third method we have seen that how the sequence of return the symbols, right, like a roman numbers. So this all represent with the sound number system in the standard way. So let us see that one. And one more he has mentioned here, the standard sequence, the number system given in the method 3, was actually the system used in the Europe before, which is called by the Hindu number system, which is called as an in a Roman number system. It is also called as a Roman number system, and it was used in Europe for the centuries, and there was a convenient for many purposes. And there was a drawback also, children. See, there was a problem here also, that one cannot write accurately large numbers without introducing more and more symbols. So we cannot write with it was a when it was a large numbers, then it was very difficult. Like for example, 23,000 or 1,564. How it's very difficult for to write that one, because it was getting more and more symbols. So for that, what we have to do? So we'll learn more about this system of writing numbers later on. Okay, so we'll see about that one. So here it represents that how the three methods are there. One, it is given by the example of a number system using the physical objects such as sticks, pebbles, or body parts. Body parts, regarding the body parts, we'll learn it in the next topic also. And names and written symbols. Some groups of people had number represent, that is both by physical object as well as by names. Like the Chinese, they all three forms of represent the symbols occurring in a written number system called as numerals. See here, how what was there? First, it was a European country, sorry, Arab countries. Then it came in with the European, with the Indians, and now it's saying that even the Chinese also has implemented with that. And that written number system, which was the numerals, like example 0, 1, 5, 30, 36, 193, etc., are some of the numerals occurring in the Hindu number systems, right? And numerals represent the smaller, and the number always had names. And so a number system composed of written symbols always went hand in hand with a number system composed of name, as in case with the modern day Hindu system. So today's day, what we are doing in a modern day, it's very difficult for us. Sorry, in modern day, it's very easy for us, right? Again and again, I am saying difficult, right? So let us see that first method what we have seen, right? So let us see what are the first method we have seen here, right? So that is the method 1. What we have seen in the method 1, that is method 1, it was by using the pebbles or sticks or etc. Okay, it was like a symbol or name, anything it was. They used to keep the name also, like how we used to call by our friends' name. How many friends are there? 5 friends, 6 friends. Even that also we can keep it. Okay, so names also we can write here. Right. Next, in the method 2, what they have mentioned here, that is method 2 by sounding or the name like A, B, C, D, dash, 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 up to Z. But it was only up to 26. It was only up to 26, A to Z. But what we can do with this 26 means is very more than that, means it's very difficult for us. So it was a 36 here. Then the third method, what we have learned, method 3, that is by the sequence of writing the symbols. Okay, that is by the symbols we can say. Yeah, Writing by the symbols. So for the three methods what we are learned is very very important here, children. Okay, it is a nothing but the mechanism of counting. So I'll write the heading here, the mechanism of counting. The mechanism of counting. And I will try to post a short video on this also, children. You can go through with this, like for at the time of exam you can recall this all things, right? So the mechanism of counting, right? So three methods are there: the pebble sticks names, all that. Second method sounding, and the third method it is a symbols. Then now let us see here the exercise what he has given here, children. The first exercise what he says, that is, suppose you are using the number of system that uses 6 represent number as in a method 1 without using either the number name or the number of the Hindu number system. Give a method for adding, subtracting, multiplying and dividing the two numbers or two collections of sticks. So let us see that first one, right? So what he has given there first method here, right? That is figure out page 54 from NCERT. Okay, the first solution, what it says. So here we can say that how we are counting the numbers with that, right? For example, if we take a groups of cow, okay, if it takes a groups of cow, we'll make it a group of two groups. Okay, first group we can say that groups of cow. First group, if we have a six cow, and second group we have a four cow, right? First we take the addition, how we add that one, right? The first addition, that is how we can do here. So here we put all together, that is all pebbles or sticks, we can say, in the same group. Okay, in the same, that put all pebbles or sticks whatever we are taking in the same. For example, we will take pebbles only. Okay, and to subtract, okay, to subtract, we can take out how many pebbles are there. Okay, take out as many pebbles. Take out how many pebbles are there, as in the, okay, take out as many as pebble from as, right? And the third one, to multiply, we can have the twice the number in the first group, like it's, we can multiply the twice. How many are there? We can twice as we can twice the number, we can twice the number in the first group, in the first group. Okay, and to divide, again to divide, what we can have, we can separate it, we separate them one by one, we separate them one by one, and the numbers and the number of pebbles gives the question, gives the question. Okay, children, right? Gives the question. So this was the main part of that, right? So first question, and the second what it says, that one way of extending the number system in method 2 is by using strings. So he's saying that one way of the number system in method 2 is by using strings with more than one letter. For example, we could use AA for 27. How can you extend this system to represent all the numbers? There are many ways of doing this. So like for example, A to Z, it was there like A, B, C, D, dash, 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 dash. It was there how much? It was going up to 26. Okay, up to Z, it was a 26. Then what about then again? Then A, one A extra S came. Then B, then again C, dash, 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 dash. Then it becomes Z, R, 26 more again. 26 more again than the previous one, right? And what about the third one? That is A, B. Again it becomes Z, Z, Z up to here. So it becomes a twice, that is They are the twice than the first one. Twice more than the first one. Okay, so it was going on increasing, so it was very difficult for that, right? So this was the answer. And the third question, what it says, that try making your own number system. So like that you can make your own by yourself. It was right. I hope you understood with this topic introduction of this, and we completed here first how the three methods was used. The mechanism of the counting was starts here, right? Let us see in the next video how the number system has been started. Okay, I hope you understood with this. And a request, if you are not subscribed, please subscribe to my channel and go through the playlist for the other topics and other classes also, and you can share with your friends or your relatives, neighbors, etc., etc. Okay, thank you children.